We have just talked about sharding and replication. Sharding enables Elasticsearch to scale the number of documents an index can store by splitting it into smaller pieces. Naturally, this is not going to help us forever if we don't add more nodes to our cluster, as we would otherwise run out of disk space no matter how many shards we create. Likewise, replication only kicks in for clusters consisting of more than one node. So instead of just talking about it, let's actually start up another node and see how our cluster behaves. In fact, just for the sake of it, we'll be spinning up 2 more nodes. If you intend to use Elastic Cloud throughout this course, then adding additional nodes is handled within the Elastic Cloud interface. You won't be able to add additional nodes on the free trial, but just watching this lecture is going to be sufficient for you. If you do want to follow along in this lecture, then you'll need to install Elasticsearch and Kibana on your machine. Now, the way you would typically add nodes is that you would download Elasticsearch for each node you want to start up and update a few configuration settings for each node. That's the proper way of doing things. There is a shortcut, however, which is useful while we're in development mode. So, which approach will I show you then? You guessed it, I will of course show you both. It should be said though, that both of the approaches that I'll show you in this lecture are not suited for a production environment, so only use them for a development environment. That being said, I recommend that you stick around regardless, as you will gain a bit of new knowledge. First, let's do things the right way by downloading and extracting Elasticsearch into another directory, meaning that we have 2 copies of Elasticsearch. I've done this in advance to save a bit of time. Before starting up a new node, we need to change its name within the configuration file. We didn't do that for the first node, so it was just given a name automatically based on my computer's name. We really should have configured a name for it, but I just wanted to keep things simple. As you have previously seen, we can specify the name within the elasticsearch.yml file located within the config directory, so let's open that up in a text editor. Now, the best practice is to also specify the name of the cluster that the node should join. It's a good idea even while developing if you're on a shared network, and it's especially important in a production environment. I won't do this now because the cluster that we already have is named Elasticsearch, being the default name. Just below the cluster.name setting, we have the node.name setting, which will uncomment and give a value of node-2. Like so. Given that we're starting up the node on the same machine as the existing node is running on, we don't need to do any further configuration. If that was not the case, we would need to configure a couple of other things, but that's a topic for later. As you might have expected, we start up Elasticsearch in exactly the same way as you saw earlier in the course, so let's head to the terminal. So all we need to do is just to type bin/Elasticsearch and hit enter. Now that the node has started up, let's head over to the terminal tab where the other node is running. As we can see near the end of the output, our new node has indeed been added to the cluster, so everything should be working fine. So that's it. That's how easy it is to add another node to an existing cluster, at least for a development environment. Before we add yet another node, let's quickly explore what our cluster looks like. So let's head over to Kibana. I've prepared 2 simple queries, both of which you have already seen. Let's begin by checking the cluster's health. As we can see within the query results, the cluster's health has now transitioned from yellow to green. That's because the unassigned replica shard has now been assigned to the new node that we added, because the requirement of never storing a replica shard on the same node as its primary shard can now be fulfilled. This means that we no longer have any unassigned shards, and all shards are healthy. Let's check how the shards have been distributed. As you know, each line represents a shard. Within the node column, we can see how the shards have been evenly distributed across the two nodes. Specifically, a replica shard and its primary shard are stored on different nodes. A small thing to notice is how the Kibana indices now have a replica shard each, which were added automatically due to the auto expand replica setting that I mentioned in the previous lecture. Let's now add another node to the cluster, just in a slightly different way. Instead of extracting Elasticsearch into a new directory as we did before, we can reuse our existing directory. In fact, we could have a single directory containing Elasticsearch and use it to run 10 different nodes if we wanted to. But how do we do that when we need to change the node names, which are read from the configuration file? What we can do is to override configuration values from the command line when we run the Elasticsearch binary. Let's open another terminal tab at the same directory as before. So usually we would just write bin/Elasticsearch like this. The way we override configuration values is by adding an E argument for each setting that we want to override. Immediately following, we specify the name of the setting, then an equals sign, and then the setting's value. Let's type that out for the node.name setting so that it's a bit easier for you to understand what it looks like. So -e node.name equals node3. That was pretty easy, right? Doing things this way, we need to change two other settings though, namely the paths of where the node will store its data and log files. If we don't do this, things are going to get messed up. The settings are named path.data and path.logs, so let's override these two settings as well. Let's store both things within a subdirectory named node-3 relative to the Elasticsearch home directory. So path.data equals the path, and then the path to the log files, path.logs, like so. Before running the command, I want to stress that it's not best practice to start up nodes like this. The approach that I showed you before is better, because each node has its own directory, and all configuration is specified within configuration files. However, the command that we just wrote is useful when you're developing and just want to quickly add additional nodes to your cluster for testing purposes. As you can imagine, copying and pasting this command and changing the node number is a very quick way to add many nodes to a cluster. With that being said, let's go ahead and run the command. Everything looks okay, but as before, let's check the output of the first node that we started up and verify that the new node was correctly added to the cluster. Just as before, we can see that the new node has indeed been added to the cluster. So that's how you can add more nodes to your cluster. As the title of this lecture suggests, these two approaches are intended for development and not production. Setting up a cluster for production is a topic for later in the course.